Alrighty, so here we are with our second section of Chapter 7. This is actually day 1. We're going to do 2 days of this because we're learning a lot of new terminology and operations. So we're going to do matrix algebra, kind of my fave. Okay, so here's our notation here, and there's kind of a lot going on. The interesting thing about matrices is that they are labeled in kind of the opposite of what you would think. So you label them by an M and an N as their numbers, and M actually represents the number of rows. So we're talking about up and down here, and then how many columns. So rows, then columns. So for instance, this one is not a name. Okay. So we also have things called square matrices because square matrix is actually when the number of rows and columns equal each other, which again makes a square not so hard to figure out. And each element within each piece has this identifying digit down here of rows and columns. So if you put, for instance, A sub 98, that's going to mean that we're talking about row 9, column 8. Now, an issue, of course, comes up when you happen to have more than one digit of rows and columns. And so I'm sure you can figure out to put in some colon or comma or something like that. But the idea is that the first number there is rows, the next number is columns. All right, and that is how you would figure out what each of these is called. So when we use matrix vocabulary, notice that we have some capital letters here that equal certain matrices. All right, and so we have something called the order of the matrix. And the order, as is said in this definition here, is just the dimensions. So if you're going to ask what the order is, you just take your rows and put an X and then your columns. So if we look at the order of A, we are going to do the rows by the columns. And so in A, we have 2 rows and 3 columns. So the order of A is 2 by 3. Then they actually want the digit that represents A13. And so remember again that the first one is your row and then the second one is your column. So they're saying we're looking in row 1, column 3. And so that's that piece right here. So 3. The next one, they're saying go to matrix B and find, again, row, then column. So find row 2. So that's this guy. And then column 1. So right here. All right. And then they're asking, is B a square matrix? Well, remember that M would need to equal N, or your rows needs to equal your columns. And in this case, our rows is 2 and our columns is 3, and they do not equal, and so it is not square. Not to mention, very much looks like a rectangle. So anyway, another thing about matrices is you'll notice that there aren't necessarily separations between each of these. So you do need to learn to kind of put a larger space between each of these so that it doesn't look like a row of just the number 523 or something, which would be weird with a minus, but anyway. All right. So then we have operations with matrices. And so in order to add and subtract a matrix, you need the same order dimensions in order to add them, because technically you would be taking the first piece and adding it to the second piece. So your new resulting matrix would have a 1 plus 5 in that first section, so a 6. Then down here you'd have the result of 2 plus 1. This first row, second column would have a negative 2 plus 2. So again, that is if you take A plus B. So in order to do A plus B, again, you need the same dimensions. If you don't have the same dimensions, then all of a sudden you are taking some sort of like 5 that's over here and adding it to nothing. So you need to have all of the same dimensions. The sum or difference answer will have the same order. So again, as we looked at it, it's not like the sum of these two gets moved over here or something like that. It just goes in that same spot. All right. And then we also have something called scalar multiplication, which really just means that k is some number that you are going to apply to each term or piece. So apply k by multiplication to each, I guess we call it element, but there you go. So again, every single element is going to be multiplied by k. So taking a look over here again at our examples, if we were trying to find 5 times a, you would have 5 times 1, and 5 times -2, and 5 times 3. All right. That's scalar. So then we're actually going to do multiplying matrices, which is pretty intricate. Okay, so we're just going to make sure that we can get there. So what you do is when you are multiplying, you need to make sure that your middle numbers match. So, for example, the title or the order or dimensions of this one, again, is your rows by your columns. So there's 1 row and 3 columns. So this is a 1 by 3. This one over here, again, rows by columns, is 3 rows by 1 column. So these are the middle numbers that need to match. Again, as I kind of mentioned in the previous example, if those don't match, you end up kind of having terms that are out there not being added or subtracted by anything. So it does need to have order. So multiplying matrices is not commutative. Means you cannot put it backwards or and forwards. So if I say a times b, that is not the same as b times a. So a times b is not the same as b times a. Can't flip it around. All right. So what you're going to do is add the product of the ith row, thank you, with the jth column. Okay, so that's kind of a lot happening here. But the idea is that you are going to add the product. So you're going to take the first piece in this row and the first piece in this column. So it's always kind of this across and the vertical alignment, which is, of course, why this number needs to match this number, because these 3 digits will be multiplied by these 3 digits and added together to make the one piece. So this one is a very interesting piece because it turns out that the result is these ones here. So this is going to equal a 1 by 1 matrix. And again, that is because of this one and this one. And so those middle terms are needing to match in order to be able to multiply. And those other terms or dimensions make the resulting matrix. So our resulting matrix is literally just one term. So how do we get that term? To get that term, we're going to take each of this first digit and this first digit and multiply it, and then add it to the second digit times the second digit. And then add that to the third and the third. So we're going to take 2 plus 0 plus 21. And so our resulting matrix is literally just the number 23. So it's kind of weird, but there you go. That's your resulting matrix. Alrighty. So we are going to complete the following operations if possible, and if not possible, we're going to state that it's not defined or not able to be added. So for instance, if I was ever to say that I want to take B and add it to C, that is not allowed because this has 9 elements and this has 6 elements. And so again, you'd have this bottom row that you're not going to combine with anything, which is not allowed. So we're going to go ahead and complete these if we can. So notice that A is this rows by columns, so 2 by 3. And this is also a 2 by 3. And so if you are adding, you can in fact add or in fact subtract things that have the same amount of elements. So we are going to take the A matrix and add it to the C matrix. And so number 1, the resulting matrix is going to be 2 plus a negative 4 for that first top left piece. Then we're going to have 0 plus 5 for that middle piece. And a 1 plus 1 for that third column top. Then the next one is going to be negative 1 plus 0, 3 plus negative 2, and 4 plus 1. So the result of A plus C is going to be negative 2, 5, 2, negative 1, 1, 5. So that is our resulting matrix. All right. Then in number 2, they're going to have you take the C matrix, which is again 2 by 3, and the A matrix, which is 2 by 3, and they're going to have you subtract each of the pieces. All right. So in order to subtract the pieces, again, it says to start with this one. So negative 4 minus 2 is the result that's going to go in the top left. 5 minus 0 is going to go in the top center. 1 minus 1 is going in the top right. 0 minus negative 1 is going to be 0 plus 1. Negative 2 minus 3. And then 1 minus 4. And so your result is negative 6, 5, 0, and 1, negative 5, negative 3. So that's if you subtract C and A. All right, and then number 3 is multiplying by a scalar. So all you do is take all of the pieces in part A and multiply each of them by 3. So the resulting matrix is going to be 3 times 2 for this center piece. I'm multiplying by 4, sorry. 4 times 2, 4 times 0, and 4 times 1. And then 4 times negative 1, 4 times 3, and 4 times 4. And so your resulting matrix is going to be 8, 0, 4, negative 4, 12, 16. All right, that was number 3. Then in number 4, we're trying to multiply matrix A times B. So matrix A is going to be a 2 by 3 matrix. And matrix B is a 3 by 3 matrix. And so remember that the only thing that we are looking for is that these match. And since those both match, we're going to get a resulting matrix that is a 2 by 3. And so we can multiply them, and now we're going to get our result. Alrighty. So the first thing that we are going to do is set up our 2 by 3. And so in order to get this first piece here, I'm actually going to write it in a lot bigger piece here because we're going to need more room. We need to multiply each row by, let me go back to this one. Sometimes I get this mixed up. Each row with each column. So row with column. Okay. So I'm going to do 2 times this piece here. So it's kind of this multiplying with these pieces. Okay, and so because I did row 1 with column 1, the result is up here in row 1, column 1. Then I'm going to do row 1 with column 2, and that result is going to go here for row 1, column 2. So first one is row 1, column 1, so 2 times 2. That's going to be added to 0 times 0. And that's going to be added to 1 times 3. So that is going to be the result to be the first digit in that upper left. Then if I do this row times this column here, again, row 1, column 2 will result in this middle piece. So 2 times -1, 0 times 2, and 1 times -2. Then the last piece of that is going to be 2 times 0. Again, row 1 times column 3, 0 times 5, and 1 times 1. The next piece is going to be this second row times each of these columns. So row 2 here is -1 times the first column, so 2. That's going to be added to 3 times 0. And then 4 times 3. The next piece is these same 3 digits, but now times this middle set. So -1 times -1, 3 times 2, and 4 times -2. All right, and then our last piece is again this row 2, because its placement is 2, 3. So we're going to multiply the second row and the third column. So -1 times 0, 3 times 5, and 4 times 1. So I guess we can use this piece up here now that we have it. And so our result of 2 times 2 is 4, plus 0, plus 3. So 4 plus 3 results with a 7. This middle term is going to be the result of -2 plus 0 minus 2, so -4. And then the last piece is going to be 0 plus 0 plus 1, so 1. Our second row, our first column, results from -2 plus 0 plus 12, so 10. 1 plus 6 minus 8. 1 plus 6 is 7 minus 8 is -1. And then 0 plus 15 plus 4, so 19. So this is the matrix that is the result of A times B. So kind of a lot of work, all right? And of course, there will be a nice, easy calculator way of doing this, but we do need to understand how it gets these results before you realize that, for instance, there's an error or something. All right, so then number 5 is trying to do B times A. And so if we go with our same thought process of the previous one, B is a 3 by 3, and A is a 2 by 3. And so remember that you cannot multiply something that don't have these matching. And since they don't match, you cannot multiply. And so that means not defined. All right, so that was number 5. Number 6 takes B times C. And so again, B is a 3 by 3 and C is a 2 by 3. And so again, that's not possible in number 6, B times C. So B again is a 3 by 3, C is a 2 by 3, and so this one is not defined because the 3 and the 2 do not match. All right, then option 7 was C times B, which again, A times B worked, so C with the same dimensions times B should work. And so we'll end up with this kind of result here. So number 7 is going to be C times B, and so notice that B times C was not defined, but C times B was possible. So C is a 2 by 3, B is a 3 by 3, and so these two pieces match. And because they match, you're going to result in a 2 by 3. And so unlike this one, where it had 2 rows and 3 columns, we're actually going to have 2 columns and 3 rows. Oh. Actually, we're going to have the same thing, 2 rows and 3 columns. Again, I tend to mix up which one is first, so I always go back to this page where I say rows and then columns. Okay. So anyway, 2 rows and 3 columns. Okay. So we are going to set up our very large matrix to show the steps. So going back to this piece, we are trying to multiply each of this row by this column. So I'm going to do -4, and that's going to add to 5 times something, and then that's going to add to 1 times something. So this number, and this number are going to be multiplied by this row. So 2, 0, and 3. So -4 times 2, 5 times 0, and 1 times 3 is going to be that first row, first column. Then we do the same row, so we're still going to do -4 times something, plus 5 times something, plus 1 times something, and that's going to be this row. So -1, 2, -2. And then the last thing, again, is still this same row, which is -4, but times this column. So times 0, plus 5 times 5. And then plus 1 times 1. Didn't run out of room. Okay. Then we're going to do this next row with these 3 columns. So we're going to do 0 for this first piece times 2, plus -2 times 0, plus 1 times 3. Then our middle piece is going to come from 0 times -1, plus -2 times 2, plus 1 times -2. And then our last piece is going to be that same row, so 0, -2, and 1, but it's going to be times 0, 5, and 1. So times 0, times 5, and times 1. All right, so now we can get our resulting 2 by 3 matrix. So we have -8 plus 0 plus 3, so -5. Over here we'll have 4 plus 10 minus 2, so 12. And then the last piece is 0 plus 25 plus 1, so 26. The next piece here is 0 plus 0 plus 3, so 3. 0 minus 4 minus 2, so -6. And then 0 minus 10 plus 1, so -9. All right, so that is the result of C times B. Okay, so then we have some more examples. Oh gosh, and some more examples and our homework. And so are these same ones? Oh yeah. This was just giving me room to work on those. So yay for me giving me that. Okay. So the assignment then is number 1 through 27, and we'll do the odds. And of course, there will be a video to help you through each of those problems if you need it.